So hello everyone. So today we are going to implement this given circuit in the MATLAB software and we'll see that how we are going to implement the Thevenin's theorem with the help of MATLAB software. So we'll discuss this numerically in detail. As you can see, there is only one source and it is having 15 volt DC voltage. Again, R1 is 1.481 K. Here K is representing that multiply by 10 raised to 3. So all the resistors that we are using here, they are in kilo ohm. Similarly, R2 is 3.25 K and R3 is 3.27 kilo ohm. And if you see here, RL is given that is 1.475 kilo ohm. And we need to obtain the value of current IL with the help of MATLAB software. So instead of wasting time, we'll start with MATLAB software. As you can see here, once you open the MATLAB software, you have to click on Simulink. So once you click, you have to create a blank model. So we'll create blank model here. Simulink. Once you have to click on Simulink, again you have to click here, create model. So once you click on create model, the simulation window is going to appear. So here we need three resistors, one voltage source. So what we'll do, first of all, we'll double click on the screen and we'll write here RLC series branch. See, direct register is not available here. So simply we need to select RLC series branch. Once we select this, you have to double click on this, that RLC series branch. Here in branch type, you have to select R. Once you select this, click OK. We need four resistors. So simply you can click here, Control C, Control V. You have to copy paste. Again one more time, Control V. Yes, if you want to rotate that resistor, simply you press Control R and you have to connect all the resistors as per our circuit diagram. Again, we need to insert one voltage source. Simply double click here, type DC voltage source. DC voltage source. So here, once you click on DC voltage source, you have to connect that DC voltage source in the given circuit. So once you collect this, we need to give the values. For that, double click on DC voltage source and type here 15. Again, similarly, we need to give the value of resistances. This is R1. R1 value is 1.481 kilo ohm. So simply 1481 will write in 1481 like this. R1, R2 is 3250. Okay, and R3 is 3270. Okay, and at last we need to give the value of RL, that is 1475. Okay, so now we have completed the circuit, but first of all, before implementing the Thevenin's theorem, we need to calculate the value of current flowing through RL. So this is our RL. So one thing that we have missed here, that we are going to add current measurement here. So to do that, double click and type current measurement. Current measurement. You will get current measurement. Rotate this and connect here in the circuit. So once you correct, we need one more block to show the value, to display the value of the current. So for this, we'll take display, and here you have to connect the display. But one more block is remaining, that power GUI. Without this, the simulation will not be run. So simply double click, type power GUI, and yes, simulation is completed. Now we need to simulate, and we'll check the current flowing through original circuit, current flowing through RL in the original circuit. Then we'll implement Thevenin's equivalent circuit. Simply click on run. So it is simulating here, as you can see here, 2%. Again, it is compiling. Once the compilation is over, you will get the result in the display. So the value is 0.001788. So this is the value of current we are getting in the original circuit. So similarly, what we will do, we will now, as per the Thevenin's theorem, step 1 is to measure the value of VTH. So simply what we will do, we will copy this circuit as it is, Control C. Again we'll paste here Control V. Yes. So now you can see. So here we are going to implement the Thevenin's theorem. So we'll remove this RL. So instead of current measurement, we'll double click here and type voltage measurement, that to measure the value of VTH. So this is the VTH. From here we'll connect here and we'll take display here. So now we are going to measure the value of VTH. So simply I will click here on run. So the is 10.3 volts. So as per procedure, remove RL, then measure value of VTH. So the VTH is 10.3. So now we need to calculate RTH. So here it is not possible to measure the value of RTH. During our numerical solving, the RTH is around 4.27. So we'll 4.27 kilo ohm. So simply what we'll do, we'll take that VTH, then RTH, and again we'll reconnect the RL. So for that, I am copying here voltage source, Control C, Control V. So here now we are going to implement the Thevenin's equivalent circuit. Again, I will copy this resistor, Control V. So here simply, so this is RTH. Again, one more time to be Control V. Again, we'll rotate this. Well, we have connected this. Now we need current measurement because we are going to calculate the value of current in Thevenin's equivalent circuit. The current which is flowing through RL. So simply double click here. Current measurement. So this is the current measurement we have taken here and rotate this. Again we need display. Double click. Take display. So display we have taken here. We'll connect display and we'll complete the circuit. We have completed. So the value of RTH is 4270. Okay. Again here we'll take value of RL. So value of RL is around 1475. So here 1475. Okay. Now we need to measure the value of current. So here voltage will be VTH, that is 10.3. Okay. Now we need to click on run. As you can see here, the current flowing through original circuit is 0.001788. Now the value of current which is flowing through RL in Thevenin's equivalent circuit, that is 0.00179. So it is not possible to measure the value of RTH here. So simply better way you calculate first and then you have to put the value of RTH. So this is VTH, that is 10.3. This is RTH, that is 4270, and this is REL, that is 1475. Okay. So if you compare all the values, it is nearby similar, 0.0071788 and it here 0.001793. So the current flowing in original circuit and current flowing in RL in Thevenin's equivalent circuit is nearby same. So hence we have proved the Thevenin's theorem with the help of simulation.